Hello everyone. In this video we are continuing with past year CAT questions from the topic permutation and combination. This is video number 3. In the first video we started from questions from old CAT papers. Whenever question is displayed on the screen, pause the video, try that question by yourself and then continue with this explanation video. So let's start from question number 24. Question number 24 is from CAT 2004. N person standing on a circumference of a circle at distinct points. Each possible pair of persons not standing next to each other sing a 2-minute song, one pair after the other. If the total time taken for singing is 28 minutes, so what is the value of n? So each song is 2 minutes, total time taken is 28 minutes. It means the number of songs is equal to 14. So total n people are there. Out of n people, let's choose 2 people everyone. In how many ways you can choose 2 people from n people? NC2. But from this we need to exclude adjacent pairs. For example, if there are 6 people are standing, if there are 6 people are standing, then how many adjacent pairs you can see? AB, BC, CD, DE, EF and then FA. These are the 6 adjacent pairs. If there are 6 people, there are n people, so how many adjacent pairs will be there? N pairs will be there. And the value of this subtraction is equal to 14. So let's solve this. NC2 minus n is equal to 14. You can take a help of options as well. Let's check option A. 5C2 minus 5 is equal to 10 minus 5. The value is not 14. If you check option B, 7C2 minus 7. 7C2 is equal to 7 into 6 divided by 2, 7 into 3, 21 minus 7, 14. Yes. So option B is the correct answer over here. Question number 23 is from CAT 2005. In a chess competition involving some boys and some girls of a school, every student had to play exactly one game with every other student. It was found that 45 games both players were girls. In 90 games both were boys. The number of games in which one player is boy and one player is girl, you need to find. So let's say number of boys are B and the number of girls are G. So among boys, in how many ways you can choose 2 boys? BC2, which is equal to 190 games. Among girls, in how many ways you can choose 2 girls? GC2, which is equal to how much? 45. So you can do some trial and error over here. So BC2 is equal to 190. So 20C2, the value of 20C2 is 190, or what you can do is you can make an equation over here. B into B minus 1 divided by 2 is equal to 190. So the value of B into B minus 1 is equal to 380. So if you solve this further, the B is equal to 20 satisfies the equation. Similarly, G into, this is G not 9, G into G minus 2 divided by 2, G into G minus 1 divided by 2 is equal to 45. So G into G minus 1 is equal to 90. So the value of G is going to be 10 over here. So now how many games are there where one person is boy and the other person is girl? So 20C1, in how many ways we can choose one boy, and then in how many ways we can choose one girl? 10C1. So answer of this question is 20 into 10, that is equal to 200. There are 200 games in which one of the opponent is boy and the other opponent is girl. The next is question number 22 from CAT 2006. There are 6 tasks and 6 persons. Task 1 cannot be assigned either to person 1 or person 2. Task 2 must be assigned to either person 3 or person 4. Every person is to be assigned one task. In how many ways we can do this? So look here. There are 6 tasks are there, T1, T2, T4, T5 and T6. And there are 6 people are there, P1, P2, P3, P4, P5 and P6. So look here. Task 1 cannot be assigned to person 1, 2. So person 1, person 2 will not come over here. Task T2 must be assigned to person 3 or person 4. So for task T2 we are having 2 choices. Now for task 1, how many choices we are having? For task 1, P1 cannot come, P2 cannot come, and one among these 2 people cannot come. So out of these 6 people, 3 people we cannot assign task 1. Which 3 people? P1, P2 and one among P3 and P4. So remaining we are having 3 choices for task 1. Then for task T3, T4, T5, T6 there is no any condition. Now 4 people are left. So 4 people are left, 4 choices, 3 choices, 2 choices and 1 choice over here. So the answer of this question is 3 into 2. It's 6 into 4 factorial is 24. 6 into 24 is equal to 144. The answer is option E. Question number 20 and 21, they are on the same data from CAT 2008. The figure below shows the plan of a town. The streets are at right angle to each other. A rectangular park is situated inside the town with a diagonal road running through it. There is also a prohibited region D in the town in which one cannot enter. Question number 20 is, Neelam rides her bicycle from her house at A to her office at B, taking the shortest path, then the number of possible shortest path that she can choose while traveling from point A to point B. So for the shortest path, going through this diagonal is compulsory. Okay. For the shortest path, diagonal is must. So let's have a look at it. Let's call this point as B, everyone. Sorry, let's call this point as X and let's call this point as Y. So how Neelam is going to travel from A to X, then X to Y and then Y to B. So over here there is a direct formula. If a grid is of m by n, then the number of shortest path is m plus n bracket factorial divided by m factorial into n factorial. So over here A to X the grid is of dimension 2 by 2, Y to B the grid is of dimension 4 by 2. The number of shortest path to travel from point A to point X is 4 factorial divided by 2 factorial divided by 2 factorial. X to Y we can travel in only one way, that is by using diagonal. Y to B 4 plus 2 6 factorial divided by 4 factorial into 2 factorial. So let's calculate this. You can see 4 factorial and 4 factorial will get cancelled out. 6 factorial divided by 2 factorial bracket cube. 720 divided by 8. The answer of this question is option C, that is 90. Question number 21. Neelam rides her bicycle from her house at A to her club at C. From A to C, Neelam is supposed to travel via B. So first Neelam is traveled from A to B and then B to C. Then the number of possible shortest path that she can choose. As per our calculation of question number 20, you can say that from A to B how many shortest paths are there? 90. From B to C how many shortest paths are there? That we need to calculate. Our answer is going to be 90 into this. So our answer should be multiple of 90. So depending on this you can try to eliminate the options. But yes, let's calculate how many ways she can travel from point B to point C. She cannot enter in the region D, everyone. So over here we need to do the manual counting. How we can do the manual counting? Let's have a look at it, everyone. Look here. Total there are 6 rows are there. So let me draw 6 rows. 1, 2, 3, 4, 5 and 6. Neelam is supposed to travel from this point B to this point C. In how many ways she can travel? Let's do manually. Neelam can travel to this point by using only one way. Neelam can travel to this point by using only one shortest path. To travel to these points, Neelam is having an option of only one shortest path. To this point as well. Now, to this point, in how many ways Neelam can travel? 1 plus 1, 2 ways. To this point, 1 plus 2, 3 ways. 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6, 6 plus 1, 7. Neelam can reach to this point in 6 different ways. So Neelam can also reach this point. This point is a kind of island. Neelam can also reach this point to 6 ways only. So 6 plus 7 is 13. So Neelam can reach point C in 13 different ways. So the number of shortest paths Neelam can travel from point B to point C is 13. So our answer is going to be 13 into 90, that is 1170, option A. Question number 19 from CAT 2008. How many integers greater than 999 but not greater than 4000 can be formed with the digits 0, 1, 2, 3, 4 if the repetition of digits is allowed? So basically we want 1000 to 4000. Greater than 999 means the minimum possible number is 1000, and not greater than 4000, it means 4000 is also included. So let's have a look at it. So what do we need to do over here is, first place can be 4 in just one of the case. Okay, so what we can do over here is 1000 to 3 and 999. We'll separate this and 4000. These are the possible numbers, everyone. So over here the first place can be 1 or 2 or 3. There are 3 ways in which we can fill the first place. The repetition is allowed, so these 5 digits, all these 5 digits are possible at each of the place. And this is one number that also we need to consider. So 125 into 3, 375 plus 1, 376 is the answer of this question. Question number 18 from CAT 2023 slot 1. The number of all natural numbers up to 1000 with non-repeating digits. So up to 1000, so what do we need to do? We need to categorize this number as a 1-digit number. 1-digit number. So how many 1-digit numbers are having non-repeating digits? That is 9. 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 1-digit number in which digit is not repeated. So now let's talk about 2-digit numbers. The first place cannot be 0, so 9 choices. Second place, out of 10 available digits, 0 to 9, out of 10 available digits, 1 digit is already used because it is without repetition, so we are having 9 choices. So 81. If we talk about 3-digit numbers, first place cannot be 0, so there are 9 choices. Second place, 0 to 9, 10 digits, 1 digit is already used, so 9 choices. Third place, 0 to 9, 10 digits, 2 digits already used, so 8 choices. So 9 into 9 into 8, that is 81 into 8, that is equal to 648 possible numbers are there. So final answer of this question is 9 plus 81 plus 648. That is 90 plus 648, that is equal to 738 is the correct answer over here. Question number 17. The arithmetic mean of all the distinct numbers that can be obtained by rearranging the digits in 1421 including itself is how much? So over here the digits are 1421. If we rearrange this, How many different arrangements are possible? Total 4 digits we can arrange in 4 factorial ways, but 2 digits are identical, 1 and 1. These are 2 digits identical, so we need to divide it by 2 factorial. So 4 factorial divided by 2 factorial, 24 divided by 2, 12 4-digit numbers are possible. So we need to find the sum of all these 12 numbers we need to find, and we need to divide it by 12. So let's have a look at it, how we can find the sum of these 12 numbers. So first of all, let's get the total value of unit place, then total value of 10th place, 100th place, 1000th place. How we can do that? Let's have a look at it. Out of these 12 numbers, how many numbers are there where 2 will come at unit place? How many numbers are there where 4 will come at unit place? And how many numbers are there where 1 will come at unit place, everyone? So let's have a look at it. 2 at unit place. So the remaining 1, 1, 4 will get arranged over here in how many ways? 3 factorial divided by 2 factorial, that is 3. Over here again 1, 1, 2 will get arranged in how many ways? 3 factorial divided by 2 factorial, that is 3 ways. And over here 4, 2, 1 will get arranged in how many ways? 3 factorial, that is 6. So out of these 12 numbers, there are 3 numbers in which 2 will be at unit place. There are 3 numbers where 4 will be at unit place, and there are 6 numbers where 1 will be at the unit place, and same thing will happen for 10th place as well as 100th place as well as 1000th place. So now look at it. In all these 12 numbers, the total value of unit place is how much? Total value of unit place will be how much? 2 will appear at unit place 3 times, that is 3 into 2. 4 will appear at unit place 3 times, that is 3 into 4. 1 will appear at unit place 6 times, that is 6 into 1. So the total value of unit place is going to be how much? 3 into 2, 6 plus 12 plus 6, that is equal to 24. Similarly, let's get the total value of 10th place. Total value of 10th place, everyone. So let's have a look at it. If I fix 2 over here, the value of this 2 is 20. If I fix 4 over here, the value of this 4 is 40. If I fix 1 over here, the value of this 1 is 10. So let's have a look at it. Again, there are 3 numbers over here, there are 3 numbers over here, and there are 6 numbers over here. So there are 3 numbers in which the value of 2 is 20. There are 3 numbers in which the value of 4 is 40. And there are 6 numbers in which the value of 1 is 100. Sorry, value of 1 is 10. So this addition is going to be how much? 60 plus 120 plus 60, that is equal to 240. Same thing will happen at 100th place as well as 1000th place. So let's talk about 100th place. It is going to be how much? 3 into 200 plus 3 into 400 plus 6 into 100. This addition is going to be 2400. And similarly at 1000th place, this addition is going to be 3 into 2000 plus 3 into 4000 plus 6 into 1000. That is going to be 24,000. So over here we need to find the average. The total value is going to be how much over here? 24,000 plus 2400 plus 240 plus 24. the total value is going to be, if we take 24 common, 1000 plus 100 plus 10 plus 1 divided by number of terms are how much? Total there are 12 numbers are there, so we need to divide it by 12. So the answer of this question is going to be 2 into 1111, that is 4 times 2 is the answer of this question. That is option A over here. Question number 16 from CAT 2022 slot 2. The number of integers greater than 2000 that can be formed with the digits 0, 1, 2, 3, 4, 5 using each digit at most once. It means without repetition. Greater than 2000, so number of digits are not fixed. Greater than 2000, it means the number can be 4 digit, the number can be 5 digit, and total 6 digits are available, so the number can be 6 digit as well. So how many 4 digit numbers we can form? Let's have a look at it. Greater than 2000, it means the first place is going to be 2 or 3 or 4 or 5. So 4 choices. Out of 6 digits, 1 digit is used. So 5 digits left over here, 4 digits left over here, 3 digits left over here. So this multiplication is going to be how much? 240. There are 240 4 digit numbers we can form. Let's talk about 5 digit, everyone. 5 digit, there is no any condition. The condition is only first place cannot be 0 for the first place 5 choices out of these 6 digits. Second place 1 digit is used, so 5 digits left, 4 digits left, 3 digits left, 2 digits left. That is 5 into 120, 600 5 digit numbers we can form. How many 6 digit numbers we can form? Let's have a look at it. First place cannot be 0, so 5 choices. Second place 5 choices, 4 choices, 3, 2, 1. So over here again 5 into 120, total 600 6 digit numbers we can form over here. So our final answer is addition of these 3, that is equal to 1440. That is option A is the correct answer over here. Question number 15. The number of ways of distributing 20 identical balloons among 4 children such that each child gets some balloons but no child gets an odd number of balloons. So let's have a look at it. There are 4 child, everyone gets even number of balloons. It means, let's say the balloons that first children will get is 2 times A. Second child will get 2 times B, 2 times C and 2 times D, because we want a even number. And every child will be getting some balloons. It means the value of A, B, C, D cannot be 0. So A plus B plus C plus D is equal to 10. So now let's use a formula of distributing identical objects in between the distinct boxes. The formula is n plus r minus 1 cr minus 1. But before we use this formula, we need to make sure that none among A, B, C, D should be 0. So what do we need to do? Out of these 10, let's give 1, 1, 1, 1 to each of A, B, C, D. So 10 minus 4, that is equal to 6. That we can do in only one way because objects are identical. So now 1, 1, 1, 1 is already given to A, B, C, D. Now what do we need to do? We need to distribute 6 in between A, B, C, D. Now sum of the variable can be 0. That is fine because they already got 1, 1, 1, 1. So now some of them are 0. That is completely fine. Now we can use this formula. 6 plus 4 minus 1 C4 minus 1. Over here, how many 4 children are there? So 6 identical objects we need to distribute in between 4 distinct boxes. 4 children. So the value of this is going to be 9C3. The value of 9C3 is going to be how much? 9 into 8 into 7 divided by 3 into 2 into 1. So the answer of this question is 3 into 4 into 7, that is equal to 12 7s are 84. Question number 14. A 4-digit number is formed by using only digits 1, 2 and 3. How many, such that 2 and 3 appear at least once. 2 and 3 appear at least once, the number of all such a 4-digit numbers. So let's have a look at it. We can solve this question in an opposite way. So let's find how many numbers you can form without 2, without 3, without 2 and 3, and then subtract. So total 4-digit numbers that we can form without any condition. For the first place there is a choice of 3 digits, second place 3 digits, third place 3 digits, and fourth place 3 digits. Total 3 to the power 4, total 81 4-digit numbers we can form. Out of these 81, how many are without 2? Without 2 means we cannot use 2, we can use only 1 and 3. So for every place we are having two choices, 1 and 3. Likewise you can form 2 to the power 4, 16 2-digit numbers. Now without 3, how many 4-digit numbers you can form without 3? Without 3, how many 4-digit numbers you can form? For every place there are two choices, 1 and 2. 1 and 2, for every place there are two choices, again 2 to the power 4, 16. Out of 16 4-digit numbers you can form. Now how many 4-digit numbers you can form without 2 and without 3? That is, for every place there is only one choice, that is 1. We cannot use 2, we cannot use 3. So every place should be 1, 1, 1 and 1. So there is only one choice for every place. So there is only one number which we can form without 2 and 3. So now, how to decide what is the final answer over here? We want 2 and 3 should appear at least once. So without 2 or without 3, how many 4-digit numbers you can form? This 1 is included here as well, here as well as here. So 16 plus 16 and this 1, this number is included 2 times. So we need to subtract it once. So 16 plus 16, 32 minus 1, 31. There are 31 numbers that you can form without 2 or without 3 or without both 2 and 3. These 31 numbers we don't want. We want 2 and 3 should appear at least once. We don't want these 31 numbers. So our final answer is total 4-digit numbers are 81. Out of these 81 numbers, we don't want 31 numbers. So 50 is the final answer over here. Question number 13 from CAT 2021 slot 2. The number of ways of distributing 15 identical balloons, 6 identical pencils and 3 identical erasers among 3 children, such that each child gets at least 4 balloons and at least 1 pencil is what? So look here. First of all, let's talk about 15 identical balloons. And there are 3 children. Each gets at least 5. So again the same concept, the distribution of identical objects in between distinct boxes. The formula is n plus r minus 1 cr minus 1. Okay, so before we use this formula, the condition is every child should get at least 5. So, let me correct, at least 4 balloons. Okay, so what we will be doing, we will distribute 4 balloons. Okay, 4 identical balloons to each of these 3 children. So now how many balloons we left? We left 12 balloons, everyone. We left 3 balloons now. So now there is no any condition, as at this point of time every child is having 4 balloons. Now 3 balloons are remaining. In how many ways we can distribute 3 balloons in between 3 children, such that if sum of child is getting 0 balloons, that is also fine. So 3 plus 3 minus 1, C3 minus 1. This is the direct formula over here. 5C2, this we can do in 10 ways. After this, the next is 6 identical pencils. 6 identical pencils. Again, there are 3 children. Each gets at least 1. So what we will be doing is, out of these 3 children, we will give 1 identical pencils to each. So out of 6 identical pencils, 3 are gone, 3 are left. Now there is no any condition. These 3 identical pencils distribute in between 3 children. In how many ways we can do this? 3 plus 3 minus 1, C3 minus 1, that is 5C2, that is again 10. After this, there are 3 identical erasers. There are 3 identical erasers. And there are 3 children. There is no any condition now. Okay, you can use this formula directly. 3 plus 3 minus 1, C3 minus 1, 5C2, that is equal to 10 ways. You can do this. So we need to execute all these 3 events, all these 3 given events simultaneously. So our final answer is going to be, for the first event we can do in 10 ways, second event we can execute in 10 ways, third event we can execute in 10 ways. So the final answer of this question is 1000.